Hello, today I'm going to talk about LeetCode question number 153, find minimum in rotated sorted array. So suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, this array might become this if it's rotated 4 times, and it might become itself again if it was rotated 7 times. Okay, notice that rotating an array one time results in this last element going first. Okay, so that's how rotation works. So if we had like 1, 2, 3, 4, we rotate it once, so this would be 4, 1, 2, 3. Given the sorted array nums of unique elements, return the minimum element of this array. You must write the algorithm that runs in O log n time. Okay, so obviously we can't do a linear scan, possibly look for the pivot point, or even check if it's not rotated, because this algorithm requires O log n times. So obviously we have to do binary search. Good thing is this array is sorted in some way before it was rotated. So doing binary search or in O log n time would be efficient. Okay. So let's think about how to find this minimum element if the array is sorted. Okay. So what is the difference between the minimum element? So what makes a minimum element special in a rotated array? Okay, what makes it special? Well, what makes it special is the previous element. Let me draw that better. So this previous element will be bigger than this minimum element. Okay? And that is if the array is sorted. Okay? I mean rotated, sorry. Okay? And one easy way to tell if the array is rotated is if the first element, okay, is bigger than the last element. Which is funny because in a sorted array you would think the first element is smaller than the last element, but in this case, if it's rotated, the opposite is true. So let's write down these findings here. A array is rotated if first element is greater than last element. Okay. And our second finding is in a rotated array, okay, min elements previous element always bigger. So for example, 2, 3, 1, this is rotated by 1, so 3 is obviously bigger than 1, okay? So here are a couple findings here, and this will help us out, okay? So how do we, I guess, limit our search area? Okay, so over long and time binary search, it is about shortening the problem here, divide and conquer. Yeah, shortening the problem, reducing our range. Okay. So basically, what we can see is if, say, our range right now is here. Okay. If this whole array is our range, and we have like calculate our middle element to be here. So if this is bigger than the last element, then obviously the minimum element has to be in this range here. Okay. And yeah. And also, if we have like 1, 2, 3, I don't know, something like this, 4, 5, and this is our entire search range so far, and if this middle element is bigger than this, then obviously our search range is here. Okay. So that's how we're gonna kind of here, I guess. So that's how we're gonna make our search range smaller. And also, at our current element, or at our like mid here, we're gonna check number 2 every time. So if like the previous element is bigger than this current element we're looking at, then obviously this is the min element in the rotated array. Okay. A couple other things. If the array length is 1, array length equals 1, then obviously answer is the only element. Okay. One more thing is if array sorted, and how do we know it's sorted? Where condition number 1 is not true, then obviously first element is smallest. Okay, so that's how we're gonna go about this problem here. Okay, now to code this up. So first off, I'm gonna take care of a couple of cases here. So if the length of this array nums is 0, then just simply return the only element that's in nums. Okay. Also, if nums is not rotated, okay, how can we tell it's not rotated? If the first element is smaller than the last element, okay. Otherwise, however many times we rotate it, other than the array length times, if it is rotated, then the first element will always be bigger than the last element, okay? So nums 0 is less than nums minus 1, then just return nums 0. Okay. So yeah, easy part is done there. Now on to the binary search part. So I'm gonna add a comment here. If nums not rotated, if nums contains only one element, okay? And here, this will be cases if nums rotated, okay? So I'm going to initialize my left pointer index, my right pointer index, and initiate my binary search while left is less than or equal to right, okay? And then calculate my midpoint here. Okay, and now first I want to check is value at mid the min element. Okay, I'm going to check here. And how do we know if it's the min element? If the previous element, okay, is greater than it, okay? So what I'm going to do is if mid minus 1 is greater than or equal to 0, okay, So let's say our minimum value is the very last element here. We want to check if mid minus 1, okay, is it if the index mid minus 1 is greater than or equal to 0, okay, mid minus 1 is greater than or equal to 0, if nums at mid minus 1 greater than nums mid, then return nums mid, okay? Yeah. So, oh, sorry, for nums greater than, oh, this is taken care of here. So if that position is not out of bounds, the previous position, if the previous index, I mean, is not out of bounds, then we check is the value previous greater than nums mid, and if it is, then return nums mid, okay? Otherwise, if mid plus 1 less than or equal to when nums minus 1, okay? So if we had our like minimum element, if our minimum element was at like the very last position, we don't want to search out of bounds. So if mid plus 1, okay, if nums at position mid is greater than at mid plus 1, then return nums at mid plus 1. Okay, so what am I doing here exactly? So for example, imagine our mid element is here, okay? So I want to check, not only am I checking here, is the previous element bigger than it? If it is, then this is obviously the minimum element. I also want to check is the next value, okay, is the next value bigger, or is the next value smaller than it, okay? If this next value is smaller than it, then we return this next value here, okay? Then this is obviously the minimum element. And these two checks are basically so that we don't go out of bounds. Okay, and if either of these conditions aren't true, then what we're gonna do is check if nums at index mid is greater than nums at position 0. Then if this is bigger than this, obviously a search range we have to limit it to here. So left is equal to mid plus 1, else right is equal to mid plus or minus 1, okay? So if like this is smaller than this, yeah, if this is bigger than this, then obviously our range is supposed to be here, okay? Otherwise we limit our search range over here. So if you have like 8 here and then 5 here, then obviously the minimum value will be somewhere between here, okay? And I try running this, okay? I'll try with the rest of the examples. And I'll submit. It should have, oops, it's supposed to be 1. If it contains 1 element only. Okay. Try again. Okay, great. Thanks for watching.